Hello, Peter.
Hey, Gadi.
It was a long time we had no challenges to each other. I'm apologizing. I had a really busy moment at work
Yeah,
and hope you had also a wonderful Easter time.
I did, and I have been challenging myself.
Okay.
In fact, today I just ordered one of those small machines to have in my tool shop at home, where I can put in steel blocks. I have this. It's a hipped powder metal made in two different alloys, and
Wow.
I'll go to heat it up, and then I will forge it with my hands in this new machine.
Okay.
Maybe I'll make an episode on that when it's up running.
As a process. Oh,
Yeah,
sounds exciting, Peter. Peter,
yeah.
I have something. Let's take it as a something special, um, less metallurgical, but
Mhm.
extremely technological.
Mm.
I'm also not a big expert in that topic, so I had to prepare,
That's
and
fair.
I love this topic. I must say, as a fan, and we
Mm.
might discuss if metallurgy, coatings, and some applications might be more used in that application if they are not yet. Maybe you will have some ideas. So let me share my screen,
Yeah, I am
and
curious to learn what
we
it is.
we can start. So, Peter, congratulations. Also, you are now by 816, as I have seen
Yes.
on the followers side.
Mm.
I'm
Oh, and 100 videos. Wow. I didn't
100
know
videos.
that.
That's a
Oh,
lot here.
yeah.
So I'm quite far away from that posting volume. What you do? I'm still, yeah, as I said, quite a busy person in this, unfortunately, management role. But still, I love that we have some time and happy that we can
Mm.
start. Peter,
Yeah.
can you tell me? By the way, I have now 999 followers, so I
Yeah.
really
It's
hope after,
crazy.
yeah, after this episode we get one more and
Yeah.
we can start to do live shows, which might be even more interactive.
Mhm.
Peter, how much do you know about space?
I've never been there, but I love the stories about space, and I made one episode on my own channel about biomining in space with a specialist from NASA, because I love these stories about going out. And in fact, when I was a kid, I had a dream to be an astronaut. And I think when I was 10, 11 years, I promised my grandma that I would bring her to the moon.
It's a
Uh,
very good topic. Yeah, then
yeah,
it's good
yeah.
good
We
promises.
we never succeeded. Uh, she died before it was possible. But if
But
she had
maybe,
lived today, I would keep up my promise.
but maybe you can take someday her ash and take it with you to the moon.
Yeah, could be.
That's a good idea. So,
Yeah.
Peter, space is growing. It's one of the most developing topics. You
Mhm.
hear a lot in internet and media about we want to go to Mars.
Mhm.
NASA restarted moon missions. We get a lot
Mhm.
of information. So today's topic is related to space. And
Mhm.
one of the key successes which help us to gather information out of space is today's topic.
Mhm.
So
Yeah.
I hope you're excited and let's
Yes, I
start.
am. I
Uh,
love it.
Peter,
Yeah.
what do you see? Is it a
Uh,
radar? Is it something? How would you describe this piece of
this is
metal?
that's radio astronomy.
Yeah,
Yeah, it's a disk that collects microwave or those wavelengths that are far longer than light.
that's a good answer. Have you
Mm.
ever heard let's say, abbreviation DSN? deep space network.
Aha, nope.
No? So this one is a part of deep space network, as
Mm-hmm.
you say, to collect waves, but not only to collect, but also to transmission to a deep space and information
Okay.
from Earth and
Yeah.
back.
Mm-hmm.
So this help us to collect the data from objects which we have sent to space, like Voyager,
Mm-hmm.
like we have now some even on Mars traveling machines,
Yeah.
and they send signals and controlled from Earth.
Mm.
And those antennas, which we see here on the picture, are the key to make it happen. So, what is DSN? It's a collection of antennas, and we have basically three of them under the umbrella of NASA, located one in Madrid,
Mm-hmm.
second in California in Goldstone, and third in Australia in Cranberry.
Mm.
What they do, they collect data, they transfer data, and they navigate the data. My question to you here, Peter, why there are three of them and with such a strange selection of locations?
It sounds like when the Earth is rotating, one of them is always in visual line to the object you want to see.
It's a very good answer, very smart. So they're all more or less 120-degree
Mm.
location to each other, and one of them is always observing the space objects back and forward.
Yep.
So if you look on these antennas, what was a surprise for me, they are 70 meters in diameter. So it's like a football field. Can you
Yeah.
imagine such a large antenna? And do you have an idea why they might be so large?
Mm. They have to concentrate the signals so because they are so weak. So by having this radius on the parabolic form, you can concentrate the signal in the I don't know what it's called the peak where the it goes down the parabolic and it meet up at the anchor.
That's a very perfect answer, my friend. So they receive incredibly weak signals. So their distance from Voyager, for example, is extremely high. It's now like I think bypassing our universe, going to next destinations,
Mm.
and the signal strength is 20 billion times weaker as your watch battery.
Yeah. It's crazy that it's
It's crazy,
possible.
yeah. Because when I was thinking and looking on this, I was not believing how is it possible, yeah.
Yeah.
And if we look on a history,
Mm.
it was established already as a forerunner for military applications in 1958. So that was the first ever time United States have launched a satellite to go to the
Mm.
orbit. And
Hmm.
to monitor and communicate and interact with that satellite, they used this antenna, a smaller one. And then after, this has developed and became another project. That's what we nowadays know as a deep space network. A
Mm.
best example is remember when Americans went to moon, there were always like a filming of this, yeah, almost like a live show. And this
Mm-hmm.
was also possible because the signal coming directly from the moon back to the Earth, with those famous words of Neil Armstrong:
Yeah.
"Small step for a man, giant leap for mankind."
Did they also in 69 have free position around the globe? Or did you not have?
No, I'm not sure if this was already in 69, but those antennas were, of course, later installed till
Mm.
they get to this principle because the development took space more
Mm.
with the missions like Voyagers, Mars rovers, and
Yeah.
others. And by the
Mm.
way, Voyagers are still tracked by interstellar space. It's very interesting, yeah?
Yeah.
So I also have here a small link. Probably people will be interested how navigate to the moon happens, because what I've learned about this deep space network, the precision of signal is so high that even if you navigate a rocket, it's better even to call back and get an correction not based on the rocket signals, but rather on a deep space antenna signals which monitor your position even more precise at the rocket itself located. So it was for me quite an impressive finding out. And yeah,
Yeah.
and think about this. The Voyager was launched in 1977, so means in
Mhm.
77 you had already three antennas, otherwise you would not be able to get a signal all the time. And
Yeah.
it's still there.
Hmm.
And it still sends signals, and we still get
Yes.
some informations out of that.
Hmm.
How
Yeah.
does it work? So, Peter, you
Yeah.
told already it does work with the waves, and you're absolutely correct.
Hmm.
What do you think? What type of waves are used?
Some radio waves,
That's
but
correct.
I don't know what the length is.
Uh, so the length of waves is the highest possible inter-round wave spectrum because it helps you to get the best signal quality. And as we learned before, you need a very weak signal to make it happen. So maybe some of the radio engineers listen to us and can give a comment. My dad, for example, was studying radio engineering as he
Okay.
was at university. So maybe he will even leave a comment. I know he's watching me sometimes. uh,
Yeah.
so you need these antennas exactly to get an ultra sensitive voice. And what is also very important about the radio waves, Peter? What do you think it is?
What is important about them?
Yeah,
Yeah, they are not disturbed by anything, and there's not a lot of noise in that bandwidth.
that's correct.
Uh,
So it's low noise.
yeah.
So
So if
weather
you
is
want
not disturbing it.
microwave, you'll have a lot of disturbance by the
Yeah.
microwave background radiation. So that's
Hmm.
a bad place to be.
Yeah, that's true.
If you take the same band length as we use here on Earth on our radios, there'll also be a lot of noise.
But
Um,
another point, I'm not sure, that
hmm?
the speed of radio waves used is same as the speed of light.
Yes, of course. I have an interesting story because now you showed the battery before and you showed the Voyager from 77 and it is still sending signals. But where does it get the energy from? Because now it's so far away, there's no energy from the sun it can harvest. So the solar panels, they are out of work. And you cannot have a battery that can work for so long time. So the energy produced on it is thermoelectric material. So on the Voyager, there is a radioactive piece that produce heat, and the heat is then collected by the thermoelectric that produce electricity that can run the radio. So that's why we can communicate with it still, or
And
maybe
it's
only receive the signal. I made an interview with a guy who is developing thermoelectrics
okay.
in one of my earlier episodes, and I was so amazed about that. I didn't know that, so I would
I've
like to share that.
It sounds cool. Like from a materials perspective, you use radiative materials which can generate energy.
Hmm.
It's very smart. Moving forward,
Mhm.
do you think there is a further development available for this deep space network? And what do you think? Would laser communication be a next step for this type of application?
Laser.
Yeah,
Uh,
because laser is nothing else as a wave as well.
yeah, but But the energy to produce the laser, I think it's too high.
No, it's not the biggest obstacle. Nowadays, it's actually because we can produce extremely high-level lasers
Yeah. Then we have to
and a cheap
shoot through
price.
the air because we have the
Correct.
air here.
Yes.
And there'll be some interference with the laser and the air molecules.
I have a link here, which is a
Mm.
YouTube video. This is really interesting to look at. And this is exactly an interview with NASA experts about lasers in space. I can only recommend to watch it because for me it was very interesting to find out and learn
Yeah.
how far we're going in this direction. It's still testing, and big
Mhm.
advantage is that let's say your rate of signal is much higher. So you can get high resolution images. You can transfer much more volume of data at the same
Yeah.
speed. Yeah.
Because you
So
have
this
some
is
short wavelengths.
exactly. And there
Mm.
is also the biggest challenges we have is the weather. So the clouds, of course, do back reflect laser signals. And
Mm.
but what I've learned from this interview is that actually over 50% of time, the density of clouds is not disturbing laser signal to go through.
Okay.
So there is a possibility to create prediction models and
Mm.
actually mitigate this cloud challenge. The
Yeah.
biggest challenge is probably what for us might be very interesting. You need extremely large scale optical telescopes to make it happen, to catch the
Mm.
signal, to get absorption of laser signal.
Yeah.
And those surfaces need very nicely thinly polished quality,
Mm.
and they
Yeah.
need certain coatings to be able to get it. And that NASA is moving extremely in that direction because it helps
Mm.
us. And I will show you a couple of examples where this laser way might be a huge advantage.
Yeah.
So, and you have it here.
Uh, yeah.
So,
You could put it on the moon
for example,
to
and
have
this is
an intermediate station.
and you laugh, but this is one of the projects now on the agenda to
Mhm.
build a station on the moon.
Okay.
And there is
Yeah.
even a mission. Um, and before I go there in details, Peter, what do you see on those images? What do you have an idea? This is the three largest projects where deep space network plays a pivotal role.
The first one looks like an image of galaxies in deep space. Could be taken from James Webb telescope.
Bingo. And this is a first ever high resolution image transferred to the Earth from
Mm.
James Webb telescope.
Yeah.
First ever high resolution.
Yeah.
Can you imagine this is a real image quality? Because before that, we had really like something like 8 megabit old
Mm.
style pixel
Yeah.
images. So the
Mhm.
second one, what do you think is that?
That could be the surface of Mars. The
Mhm.
Mars rover driving around looking for life signs.
Bingo. So this is a camera located on a Mars rover directly giving you a signal so people can see what's happening there. And the
Mm.
third one, it's simple.
Yeah, that's the moon.
Yeah. So, and this is free as you currently explored the James Webb Telescope,
Mm.
Mars rover, and Artemis moon missions. And that's the quality of images and information we gather and collect. Why moon is important, because if we want to build something there, we need to know the surface quality, topography, and everything
Mm.
like that
Yeah.
to choose the right spot to start working on.
Yeah,
So
good
we're
idea.
still on a very, very baby phase, but we're moving in the very exciting direction.
Yeah. What is the time for a signal to go from here to Mars? Is it 15, 20 minutes?
That was my question to you, my dear friend, actually.
Ah,
You're too fast. Yeah. So long does it take to send a signal to Mars? What do you think?
then I would say 17 and a half minutes
Why? 17
because
and a half.
that was between 15 and 20 as I asked.
So independence where Mars and Earth are located to each other based on the orbits.
Oh,
And
yeah.
considering that the signals are traveling at speed of light across solar systems. Sorry, I'm too fast. I don't have answer here, but it is between 5 to 20 minutes. So you're in a range.
Okay.
Can you imagine?
So
5 to
yeah,
20 minutes to get information from Mars.
yeah, and that's also why it's difficult to control the rover from here. It
but
has
it's
to
still,
be driving on its own.
yeah, but the quality is improving and signal quality is improving. Yeah, if in 20 minutes there something happens, you realize it's only 20 minutes later, which is might be too late to react.
Yeah.
But we will move further, so we will definitely beat some spaceships which will build a system in between, and then you will probably have an accelerated signal.
Yeah, it could be.
Let's see. We'll move. So, Peter, to catch up, there are 5 simple questions. What is the main purpose of deep space network?
To be able to receive signals from outer space.
And?
Far outer space.
And? Not only receive, but also send.
Also to send, yeah.
Yeah. So, heck, do you remember the locations of these space network ground stations?
Canberra and Madrid and California.
Correct. Why are those dishes so large?
Because the signals are so weak. 20 million times weaker than a battery.
Excellent. And what kind of communication bands are used?
It's radio waves.
And the future might be?
Ooh, you love your laser.
as a laser expert, or not expert, a laser fan. Yeah, I believe it will have applications. Yeah. So, Peter, now we jump to a conclusion. I hope you enjoyed this small quiz on Deep Space Network, which gives you an idea. Yeah. It's a great topic. I really hope people will also try to answer the quiz and learn something new. Maybe there will be some discussion started to help us to maybe get some interesting comments. Maybe somebody is more involved. I know some NASA guys might be even listening to us, at least those who I know from my network. And then, Peter, to you, a question which is not a part of the quiz, but a topic for open discussion. How metallurgy can improve these space network structures? How we can get more stability? Do you think there are some approaches possible for that?
I have seen that there are some of these disks around the globe that they are worn out due to corrosion.
That's a very good start. Corrosion is a huge topic.
Yeah, they were built in steel, and they are out there day and night, 24/7, rain, snow, whatever comes. So if you don't maintain them, they will just corrode away.
That's correct.
So I have seen some of the very big ones. They have been taken out of service due to corrosion. And that's a shame. So you have to use proper material or proper surface treatment.
Okay, Peter, I would stop somewhere here. I would just say, Peter, I hope you enjoyed it. It was great to see. You are very knowledgeable. Despite not knowing the topic in details, you answered all the questions perfectly. Congratulations.
Thank you. Thank you.
I'm looking forward for a new quiz from your side.
Yeah, maybe I have qualified now to be one of the first to go to the moon.
From theory, yes. The question is now how we put it on like your physical conditions.
I'm ready.